Good afternoon, everybody. At the outset, I would like to thank everybody, esteemed jury. So I'll be speaking about the learning curve in the construct of a smartphone-based keratoscope prototype for keratoconus screening. No financial interest. We all are aware that keratoconus is a progressive ectatic disease, and advanced stages have only option of surgeries. So early detection and treatment to arrest this progression and prevent the vision loss is very essential. So the need of study is India. Actually, when you see the keratoconic population is extremely high because of the thin and steep corneas as well as the irritations and eye rubbing. Investigation modalities used for screening, usually the Placido-based like Keratron to that of Pentacam, are all non-portable and are very expensive. So early diagnosis with respect to these machines actually becomes inaccessible to majority of middle and lower income. So with this in our mind, our institute planned a collaborative study with software professional, and we made an attempt to create a smartphone-based keratoscope prototype, and we developed did a validation of a diagnostic model called Smart KC. So in this study, what we analyzed was the steep learning curve with respect to the device, the prototype per se, the image quality with respect to it, how we could convert and change things in the Smart KC app, and last about validating this with a standard gold standard like the Keratron machine. So this is our Smart KC which I am showing. I have a small prototype to show also. So here, the first thing we had the challenge was what Placido's design we use. As we all are aware, the ellipsoid one is very bulky, whereas the planar actually cannot occupy the peripheral, only takes the central. So our final picture was just a conical thing which we took, which had 28 points, 360 degrees, which gave nearly 1008 point of capture, and hence we utilized that as the Placido's design. When we got this, we had other issues like the working distance gap. As you can see, the distance between the cornea and where the machine sits, this is the gap top. Any subtle change in the way it sits can cause either the cornea to look very steep or it can make it look like flat. So we get erroneous reading. So what we did was we went ahead with a simulation model with our software people, and they created a sphere, used the same light parameters which are used on the keratoscope and the machine, and did multiple revisions to find out and came out with a regression formula which was applied after taking these pictures so that this gap error is totally taken care of. So with this, we thought we did and we went ahead, but no, we had issues like tilts and offsets. Here we knew that we had taken 28 points, so if by chance the image was turned downwards or upwards, we used to get steeper areas which were closer. So for this, we came up with the introduction of a plus Meyer into the app, which would make sure that the quality check is done even before the picture is taken. So here I'm just showing you the video of our Smart KC. So this is assembly. This is actually a machine. What is important here is ours is a very cost-effective machine. This, a small paper. This is a butter paper of 2 rupees. This is a 3D model of nylon material which is just prepared with a ring inside this, and we have these LEDs which are put. The total cost of this comes up to just 2,500 rupees. And after assembly, it is attached over the eye, and these are the rims, as you can see, the internal, which give very clear Myers over the cornea. This is how the workflow is. It is an app which anybody can use. Here, our single trained optometrists were using, entering the patient data and taking into consideration of the picture obtaining through that. So what is the speciality here is the image would not be captured until the quality check is done in real time. It is not later that the alterations are done, but in the real time you can see this red mark, which only once it shows that the image is good, then only the capture is taken, otherwise it is self-deleted at the same time. So this is how the picture is taken. So exposure, sharpness and offset is considered. Once this is done, this is the pipeline. What we do is once the picture is taken, we go through the imaging, that is the cropping of it, then enhancement and the Meyer detection. After this, using the basic concepts of optics, that is the angle of reflection is angle of incidence, we use these 2 steps, that is the arch step method and the surface creation by Zernike polymers, by which we create the cornea. Then using the same form, what is used as the simulated K color maps are created, and we come up with a heat map through this machine. once we did this, the litmus test was whether this machine is capable of screening as equal to a standard keratron. So we did this by taking the patients, and we went ahead with one cases, and we found out that there was nearly 100%, 92% of specificity, and we had issues when the SIMK computing was wrong. There was a movement error here, so the SIMK was taken initially for 5. Once it was corrected to 3, we got repeatable images as similar to that of keratron. So this is our results. Many studies have been done, but our study is a real-time study where we have even the heat maps coming up. Limitation is, though we have done it, it is in a number, but it is a big number of nearly 57 eyes. And though we have used a single machine, we are hopeful that it can be used on any camera with 12 megapixel availability. And we need to try it with a little bit of more people who can use it. So to conclude, this study highlights the learning curves in a construct of the optical prototype, and it has a very good sensitivity and a very better specificity than the keratron machine. Hence, it is a good screening device for picking up keratoconus. Looking forward, we are trying to go and modify this more. So thank you. I would like to acknowledge the team, and these are my references.
Very good, Dr. Sri Ganesh.
Yeah, nice presentation. I just want to know, how did you ensure fixation?
We have done, fixation was ensured by using the principal axis and the reference axis, sir.
Yeah, but does the patient have a target to fixate?
Yes, sir, there's an internal
There's
target.
an internal target. Is it a light that he can see?
Yes, sir, there's one small cross that the patient can see through.
Cross, is it visible?
Yes, sir, yes, sir.
How did you reconfirm that the patient is fixating?
We are confirming by seeing that the picture that gets aligned there. They have seen that the patient is fixating, only then the capture will be, that is being modified in the app, sir.
Okay. And what about angle kappa? Can you measure angle kappa? Because that is one of the big fallacies.
Yes, yes, sir.
If you have a large angle kappa,
yes, sir,
then you can get skew.
Yes,
and
surely.
When you have skew, it diagnoses it as keratoconus.
Yes, yes, sir.
Okay.
Yeah.
So that is something that has to be taken care of. So if your device is not measuring that, that can be a problem.
Yeah.
And ensuring fixation, because the patient is looking up or looking down,
yeah,
then you can again get a asymmetry.
Yeah, that's what I told you about the tilts, sir. That is how we assess. We had issues and fixation issues. Yeah. Both of it was corrected.
Tilt you can get with the device, yes, or if the patient is moving the head.
Up and down.
But apart from tilt, if he's looking it in another direction, correct, when you're capturing the image, if you look somewhere else, so probably you need gaze tracking also to be incorporated to be sure that he's fixating properly. That is one thing. And then angle kappa. Otherwise, you can have, these are the fallacies.
Yes, yes, sure. But we compared it with the keratron, sir. The same patients, when we did the comparative this, the pictures are coming the same. So probably it is not the direct evidence, but definitely an indirect evidence the image is captured as much as clear as we do it on the keratron.
So, Dr. Pallavi, I have, some reservations on this, because okay, the intention is very nice and you've captured it very nicely, and congrats for coming till this stage.
Thank you.
But the thing is that an asymmetric bow tie, number one, is not always an indication of keratoconus. Skewing, asymmetric bow tie, skewing under a particular limit can be there in normal population as well.
Yes.
These days we detect very early keratoconus based on changes in the posterior cornea.
Yes.
So even for a screening tool, just because you're seeing asymmetric bow tie, that is not a detection of keratoconus. And if you want a screening tool, retinoscopy works even today very well. So you will be able to see doubling of the retinoscopy or doubling of the Myers in retinoscopy even in today's context. And if you are not going to address the thickness of the cornea or the posterior cornea, a screening tool may not be really that valuable.
Thank you, madam. Just to add a point here, actually, this is the initial learning curve. Basically, the paper what we presented is the construct learning and what issues we had and how collaboration with the biotechnology and the engineers helped us out. We are actually into the second phase where we are including the PPK as a part of this, and we are using the AI and deep learning where we are trying to come with an algorithm where we can include, where we can actually pick up the early, late, and delayed. But yes, as a screening, we may not be able to do the forme fruste where we look for the posterior floats and the pachy. But just to imagine, even if this gives us a picking up of around 20% in the which we are not picking and whom we keep doing DALS and PK, it would be still a screening tool. That's the intent behind the study.
Yeah, as an early detection of keratoconus, it is not ideal because see, the epithelium masks the early changes on the anterior
Definitely.
surface, so you need to look at the posterior curvatures also.
Yes, yes.
And you need to look at epithelial maps because they are more sensitive. Epithelial thinning can be one of the first signs over the keratoconus. And these are things that you cannot see with this because it's equivalent to a placido disc, essentially. And you're using software, the same software. If you're an experienced surgeon, can look at it through the, and like the retinoscope is a wonderful tool because you can get early scissoring and you can pick it up. So whether this will have practical application for screening is a question mark.
Yeah, our intent is mainly for the school screening where we can use it along with, we are doing the, vision and retinoscopy. So maybe we are also doing on the retinoscope with the same thing. So we'll collaborate everything and try to come with a better screen too.
Dr. Joshi, congratulations. Just one quick question.
Yes,
what was the time of scan?
Time of scan, how long it took to do one eye? Around approximately, it was a single data collector, so it took around 10 minutes maximum with a little learning for the patient.
Your Myers are going to get distorted with a tear
No,
film?
no. So I meant the whole process, not the capture. Capture is in just a matter of 5 to 10 seconds, madam. That's all.
All right. Thank you.